Hello everyone, in this video we will see another problem of prefix sum, and that is running sum of one D array. Okay, so this is 1418th problem in LeetCode. Given an array nums, return the running sum of nums. Okay, a running sum is defined as, so I'm going to explain you guys easily, right? In other words, each element in the output is the sum of all elements from the start of the array up to that index. Okay, so if you see these 1 2 3 4, this is an array, and if you see the output, first one is 1. Okay, and then 1 plus 2 3, you understand? 1 plus 2 plus 3, that is 3 plus 5 plus 1 6, right? And then finally 10. Okay, so if you see here, we have 4 numbers in the input and we have 4 numbers in the output too, but we are adding them each time. Okay, so first time is 1, and then in the second place we are doing 1 plus 2 3, right? In the third place we are doing 2 plus 1 3 plus 3 6. In the fourth place we are doing 1 2 2 plus 1 3 plus 3 6 6 plus 4 10, right? So this is what we are doing here. So what we will do, we will visualize, simulate the program, and we will try to understand what's happening, and finally we will see the time and space complexity, right? If you see here nums 1 2 3 4, and we are finding num size and then return size. So this is return size. Return size is how many numbers would be the array in the array. This will define by the return size, right? And then we have a result array. So what we will do, we will take the result. How many numbers? 4, right? So let's say we will take 4. So here result 0, result 0 is result 1. This is how it will work. Okay, this is 1, result 2 3. So I don't want to waste some more time. Return size would be the one number only. Okay, so this is going to be only one variable here. This is not an array, so we need to go to the running sum, and then we will consider about this thing. Okay, let's go to the running sum, but copy the numbers, copy the array. Okay, so as you see in the result we have the pointer, but in the previous video we didn't see that the result, right? This is because in the previous program we had output only 3, only one number. That is why there was no pointer here in the result. Okay, but here we have uh, we have to return an array. Okay, so there will be many numbers here, you understand? So if you don't understand, I am going to show you actually what is happening, right? So run it. So you see we have an array, many numbers, 1 3 6 10. So this is why we need to have the pointer, right? So yeah, it is 1D array. Okay, only one array. That is why we are giving only one pointer. But it was a 2D array. If we had to return 2D array, 2 arrays, okay, then we had to provide here like this, right? Anyway, so we will see that kind of problem too, but not today. So here running sum nums, num size, ampersand return size. Okay, so we are going to the running sum now, but we will take the numbers with us, right? So come here, running sum. Okay, so num size, return size. Num size is only a number, and return size is a pointer, right? So result, we made the space for the result array. Okay, this is result. If result is null, return null. Okay, so result is null. In our case we have numbers, right? Return size equals num size. Num size is 4, so that means return size would be 4. Okay, we're defining this. Okay, we are defining that we will return 4 numbers, right? Calculate the running sum, right? So result 0 equals nums 0. So if you see guys, I'm going to show you first iteration. Okay, so 1 2 3 4 result 0 is num 0. So num 0 is 1, right? In 0th position we have 1. So result 0 result 0 would be 1. Result 0 will have the value 1, right? So now iteration will start from the 1. Okay, so I starts from 1 and num size is 4, right? Num size is 4. So result I, that means I 1 here, result I equals result I minus 1. So what is I guys? 1. 1 minus 1, that means 0. So what's the value of result 0? You understand? I is 1, 1 minus 1, that means 0. So result 0 is 1, right? So we will provide 1 and the nums I. So I is 1, in nums I, that means 1th position we have 2. So that means 1 plus 2 is 3. So result 1 we will put 3, right? I hope you got what's happening here. Okay, so maybe in the second, let's go for the second iteration. Second iteration, I starts I is 2 here. Okay, so I is 2, result I minus 1. The 2 minus 1 is 1. In the in 1th position we put 3, right? So this will give us 3. Do you understand? Because I is 2, 2 minus 1 is 1. So in result 1 we put 3. So this will provide us 3. Nums I 2, I mean when nums I 2, right? In 2th position we have 3. So 3 plus 3. In second position is okay. So in 6, right? So here we have to provide 6. The result 2 would be 6. Now we will go for the third iteration. First, second and third. Third iteration, I would be 3 here. So 3 is less than 4, yes. So result 3 would be 3 minus 1, that means 2. Okay, so in result 2 we had 6, right? 6 plus, and then this when I is 3, 0 1 2 3. So here would be 4. So 6 plus 4 would be 10, right? So in result, the here this should be 10 and this should be result 3. So 4 elements, right? 0 1 2 3. So 4 elements. So we can't take one more iteration because 3 is less than 4. If you want to try one more, then this this should be equal 4 4. So there is no more iteration possible. So now return result. So we will return the result now, and the whole result array, this whole array 1 3 6 10 is being returned, right? So finally this is going to have the whole array, right? Result is going to have the whole print running sum. So we are trying to visualize this again. First iteration, I starts from 0. Visualize guys, this will help us to really understand the problem, right? Return size is 4. So printf result I, that means result I means guys first one, right? So first one will be 1, and then we have to take second iteration. Second iteration, I would be 1 here. 1 is less than 4, fine. So here this would be 3, and then 6 and 10, right? In the third iteration, I would be 2 is less than 4, so 6 here. And then fourth iteration, finally we will 10, fourth iteration. So here you see 3, here we'll print 10, and then we'll print a new line, and then we have to free allocated memory, right? So we have to free result and then return 0. I hope you got the whole program, and we will see the time and space complexity of the program, right? If you see, okay, uh, we are providing the solution here, and give me the time here is the time and space complexity of your program. ON, the okay, region. The program computes the running sum using one loop that goes from index 1 to n minus 1, right? So this is why it's ON. It doesn't include, okay. So from the beginning, from the first one to the last one. So it's a total time ON, space complexity, also ON, region. You allocate a new array, okay? Yeah, space complexity would be the ON as well, because we are allocating an array of result, and this is we need to store the total 4 numbers. Our input was 4 and our output is 4 too, right? So space would be uh, space would be ON as well, right? If you want, I can also give you an version O1 extra space, step by step diagram. Okay, so I hope you also got this program. Okay, so thank you for watching. Try to simulate each part, and if you need the code, or maybe if you need any help, let me know. I will provide you the code. Thank you for watching.